Hello, hello, mic check. Hello, hello, mic check. Hello, mic check. I'll verify. Hello, hello, mic check. Hello, hello, mic check. Hello, mic check. Yes, it's working. Stress. See the full video. Second is see the programs. Third is program on your one without saying what this in case of errors from the check with the actual code. In case of errors, check with the actual code. At the outputs of our programs and get going. whether it works, but let us try.
So in our program, we'll check the pin numbers in our program. You can see D is 8. Okay. So it's in that order. String. So you can see whatever I've written, it will be. You can see the examples here in Arduino examples. An example function is for once we get the increase or decrease depending on the position of material. Sensor. It is using pins in different cases. We use the pins as input pin, digital output pin. In all those cases, we use the pin mode function. So the sensor is LM35. It's a temperature sensor. Okay. So it's used for measuring the temperature. Basically, this is a. If you look up the look up online, if you look up the images of the LM35 specification, basically a transistor circuit with the 3 terminals. Okay, same as any other transmitter. There will be 3 terminals. So one data terminal through which you can measure the measure the variation in temperature. Then one positive and one negative terminal. So in normal transistor, it will be collector, base, and emitter. Then like that here also there will be 3 pins. Okay. So it is a transistor and it is susceptible to temperature. It is very sensitive to temperature. So if the temperature increases, output of LM35 sensor will increase. But it will not be in the range of normal units like degrees Celsius or Fahrenheit. It will be in this range 0 to 1023 if it is a 10-bit ADC. In our case, it is a 10-bit ADC. If it is a 8-bit ADC, then the value will be from 0 to 255. Okay, because 2 raised to 8 means 255. Okay, 2 raised to 10 means 1023. So 9-bit means 511. Okay, same way we have a 10-bit ADC, so our value is from 0 to 1023. Okay. So then first we'll write the serial begin, then void loop function. So inside void loop function. So in here, like I said, in case of digital pins can have 2 directions, input or output. We need to choose the direction. That is the purpose of pin mode function here. Pin mode. We use pin mode function in every other case, but in our case we are using an analog pin. For example, if I connect this to A0, that means we don't need to convert, configure or declare A0, because A0 is if you use it in analog mode, it is only an input pin. Okay, so always an input pin. So we do not need to configure the direction, input or output. So we can directly write the value here. So just use an integer to store the value in the value. In val, then we save the value inside using read the value using analog read function. So this is the function to read analog. If you have analog sensor, this function can be used for reading the value from the analog sensor. Okay. It can be the same program can be used for any kind of analog sensor, gas sensors or sound sensors or any other kind of analog sensor. Then at last print the value. Print temperature. Ln. So this means it will print in the same line. First it will print the temperature, then temperature value. Print will be printing. So here print ln means next time it will print on the new line. Print on a new line. So this is our program. Execute. Compile the program. And then after compilation, go to simulation. So we'll keep all this. You don't need to add any sensor library because the LM35 is inbuilt in Proteus. Okay, so it's a symbol like it's the same like a potentiometer. So it is inbuilt in Proteus. You don't need to add any libraries. Okay, so to select LM35, just same pick device. There you can just type LM35. So in which type LM358? All these are op-amp ICs. We don't need this. 3580 means all these op-amps. This is our precision centigrade temperature sensor. So I think maybe in this case it will give the value in degrees Celsius. We'll see. So you can see there are in case of a real temperature sensor, you have to connect these pins to like there will be a pin output. You have to connect exactly VCC ground. So I'll show you a picture. So you can. So this is the LM35 sensor. You can see it's same as a transistor, and here you can see all the pins. One means a supply pin. Okay. 2 means the output pin. 3 means ground pin. So to connect exactly these pins. So if you interchange this, the sensor will be short and it will damage the board or at least the ADC module. So ADC pin will be damaged. So if you have hardware, you need to connect this carefully. Okay. So these are the 3 different pins. So we'll connect all the pins here. So first we already saw that. Okay, second pin is V out, so I'll connect it to A0. Pin is A0, connect it to A0. Supply pin and VCC ground pin. So first pin is supply, so the power supply. You can connect it if you have connected some supply here. You can connect it to that supply. But we don't have any supply pin, so we'll select a new supply. Then 3.3 volt. So that is a voltage of LM35. 3.3 supply voltage of LM3. I don't need to give 5 volts, 3.3 volt is not 3.3 volt. 3.3 volt, and here the ground terminal. Okay. I will just start the program and execute the program. Here you can see it's printing temperature. Yeah, it's an ADC value actually, that's why. Okay, you can see it's 27, here it is printing 27 degrees Celsius. The value is 56. You can change the value here. You can see the value is increasing. So in simulation, since we cannot use any real sensors or anything, we have to use the same thing. You have to manually increase and decrease the values, same as we did with the ultrasonic sensor. The ultrasonic sensor, there is a test pin. Using the test pin, we can increase and decrease the distance. So same thing here, increase and decrease the value of the sensor using the plus and minus importance here. Now you can see it's decreasing. Now this is in degrees Celsius. Corresponding to that, here the values, ADC values only. So this is a normal like analog read function, analog ADC program in Arduino. So why this program is it's very simple, because we are using Arduino and we can just directly use this analog read function here. So if you take any other controller, this will take more than like one step. Take like so many steps to write the simple analog ADC program. Here in case of Arduino, the analog read function is already inbuilt in this script. So that means every like supporting program and everything is in background, so we can compile with that program and decompile this. So we can read it. So it will be slower than normal functions, normal like other programs. It will be easier to use. You don't have to study a lot of things. So if you actually want to program ADC in Atmega 328, that is our controller. Atmega 328 is our controller. So if you want to actually program the ADC in that controller, then you have to study the internal architecture of ADC and all the registers. Then you can use some other platform to program, like Animal Studios or something to program. So it will take more time and more steps to do that program. Here you can do this very easily with one single step. So that's why Arduino can be used very effectively for like easy prototyping. Okay. So then next we'll wind up a class with a simple example. We'll add this to LCD program. So this is a simple program. I hope everyone did it. So we'll add this to LCD program and we'll print the temperature in LCD continuously. Okay. We'll see the program for that. We'll change the LCD program that we already have, and then add the analog, the analog program to it. So we already written the LCD program here. Don't need any of this here. So first thing, declaring the analog. So everything else is same, only change the values in void loop, lines in void loop. So first we declare the variable, then read the value. Is 0. Then again use the LCD function to print the values. So this is a very simple operation. str. So first we need to send the commands. Command clear the LCD 0x01. EMD first line 0x80. You can try other different kind of commands using the command text. Already sent you set text file. Try all the different commands there. So then the first string. So in first string we'll just say temperature. Temperature. So double quotes. Temperature. And in next line means force the cursor to second line. 08 C0 will send the send the value. So the value is in integer, but we don't need to. So we don't need to use the string variable. We can directly use this data here, but the input should be a character. So this means I'm just converting the integer value to a character using this star function. So it is typecasting, converting the changing the type of this function variable here to character. So it's not variable actually. We're changing the type of the value inside the variable. So then give it small delay so it will print for some time before reading the next value. Just give 100 millisecond delay. We'll see if it is working. So same simulation. I think we have to change the program file here. Yes. Okay. The program will see our output. We'll print the temperature here. So it's not, the conversion is not proper, that's why it's printing plus plus plus. So we'll use string function instead of character. We'll use the string function instead of data function. str character string. So this means the integer value will be converted to a string, then string will be transferred. So we'll see if this is working. So here I change the character to integer string here. There's another problem because we cannot input the string. It's a We have to convert it into character array. So we'll do one thing. Same thing we did before, character array, declare a character array. Some size. Compiling, it's not done compiling, we'll see if it is working. So you can see it's working, printing the values. You can decrease the temperature, so the value will be printed on the LCD there. Okay. So this is a basic LCD temperature sensor. If you're making a temperature reading reader or something, some kind of application using Arduino, you can use the same program. Program can be the same, but when you do the hardware, then you need to connect some other things. So hardware will be a little bit more difficult and different from the simulation. So we can use the hardware here. You can use the same program if you have the hardware. There is no difference. It's exactly the same program. So here, at the last step, what I did was here I cannot directly input the integer using data function or str function, because both the data function and str function have character data type. Argument is character data type. Okay, here data is also in data also character data type, and in case of str function it is pointer data type, character array pointer data type. So we need to, but in our case our analog value is temperature value is in integer. So then convert the integer value to a a string. Then after converting so here we convert the integer value to a string. And after converting this to a string, convert it to a character array, so we can give input to str function. Input as a str function. So that is what we did at the end to change the program. Okay. So this is the normal LCD. LCD with an application like analog, any sensor value if you want to print, you can use the same program here. Or if you want to use the, so if you, for exercise, you can use the, ultrasonic program that we did last day, and then you can print the ultrasonic value on the LCD. You can try that on your own. You don't need to, post the videos or anything. You can try it on your own. Just understand it. So if you have any doubt or anything, you can ask. So otherwise we'll wind up the class. So then I will share the videos and every files today. So hopefully tomorrow, maybe day after tomorrow, we'll start the IoT classes. So Tomorrow maybe we'll continue with the embedded system Arduino programming, and the day after tomorrow we'll start with the IoT. So IoT means I have some hardware, so I cannot share the hardware, so I'll explain the working and everything, and I'll show the demos of how it will work, and I'll explain different protocols and how they work and how we can use them, or different kind of cloud services that we can use in IoT. All these we'll see in the coming days and next week. Okay, so I think we'll conduct the class on Saturday. So if there is a festival is there, so if most of you are not able to attend the class, then we'll postpone to next week, or if we are able to finish this whole session in 13 days, we'll do that because we can add some 15 minutes or something extra every day. So we can finish it in the same time frame. We can finish it in 15, by Friday. If not possible, we'll take an extra class on weekend. So since there is a festival, we'll not be conducting class tomorrow. I think most of you will not be able to. Not tomorrow, Saturday. We will not be able to attend. So we'll be conducting it on the last week, Saturday. Or if you don't need the time, we'll just finish the class on Friday. Okay. So you don't have to attend the class on Saturday. So thank you guys. If you have anything to ask, you can ask me. So otherwise, we'll stop the meeting. Okay, we'll see you tomorrow. Thank you.
Okay, there are 4 programs in this experiment. Let me explain each of them. First we will go to Arduino. So the program is ready, but we have to type again from the first void setup, void loop. First void setup void loop. Let me start with void setup. Okay, there are 4 input output pins: digital, read, write, pin mode. Four, 5, 6, 7. 3, 4, 5, 6, and 7, 8. 1, 2 are reserved. 3. Program to input a string from Bluetooth module and display it on LED board. Okay. Pin mode. Pin mode 3 is output. 4 is output, 5 is output, 6 is output, 7 is output, 8 is output. 4, 5, 6, 7, 8. D7, it is control C. D6, D5, D for D4, 5, 6, D7, D6, D5, D4. 7 will be my enable pin and 8 will be my register select pin. Then as there is this one with the serial dot begin 9600, and there is also another thing. What is that? Serial dot begin 9600, and then anyone who can tell me what is the other thing left? The other thing left is LCD init. Now we will start with 1000 void read. What will be char ch char temp equals, okay, temp equals ch and then 0x 0f. First upper bytes of 0 and it start ending it. Okay. Digital write three comma okay, what you write 3 4 5 6, so 6 comma 0x temp and 0x 10 0x 20 20 4 0x 40 3 0x 1 2 4 8 0. Digital write my enable pin is 7 high. Digital write 8 is register select 8 high. Wait for 10 micro 1 millisecond. Crossing. Digital write 11 row and then only delay. Then D7, D6, D5, D4, 24, 3, 4, 5, 6, 6, 0, 1, 0, 1, 02 04 08 1248. And copy this. This will be the same for CMD except for then void LCD net copy that. Delay 1 CMD 0x 02 control set control set Alright. 1 2 3 4 5 6 7 2 3 4 5 6 7 0 2 28 08 01 06 06 80 228 816C 80 816C 80 delay 1. Now this is the only part which you have to look up. While loop start. Start. Okay. Serial dot read string until void string str s while stars read stars plus plus plus. ಇಷ್ಟುಕೊಂಡೆ ಎಷ್ಟು ಟು carry control X control V carry of 20. Let's see the size of set. And there is say of 20. Wait for the character to be arrived. Once arrived, say there not available. Away. While string is equals string is to array. The string is read, it is converted to character array. Is to character array. C size of C, and given all those limits, I believe by change now. That's all. Actually, not change. Things periodically it happens because of pattern. I don't know what to do. Maybe just until I know what to do. Let's see things. Okay. S2 character start to char array. It is converted to char array. Now str of C. C further CMD 0x 01 CMD 0x80. Let's change it. And here converted a factor and display. Variable void. You check the capital letters. Let's copy this. See, notice. Add professional. Color icon. Start. First keyboard. So go here and calculate this Arduino. That is the most important first. Yes, okay. Then you need a virtual terminal to place virtual instrument, virtual terminal. TX is connected to RX and RX is connected to TX. And save it as in desktop Arduino and Proteus files. Pro 6 is my okay, so that if it goes, there's no problem. Okay, virtual terminal is done, that is Bluetooth module. Then comes, here is the where we are entering. Then comes the LCD, go to some IP devices, liquid crystal display, that is the 16x2 16x2 alphanumeric LCD. Then 3 is D7, 4 is D6, 5 is D4. Save it. Go to Arduino and enable is 7. Enable is 7. So wait will be 8. Then comes, keep on saving it. This is Pro 6, okay. Then click on this around. Deviate into ground. Yes, the connections are done, I guess. Only these many connections. Okay. Save it and hello. Hi. Hello. Code type characters where you or my name is KP. My name is KP. Where my father is PD. My mother is Henry. Stop there. So it is done. Then worked. So this experiment is done. Next we will go to analog sensor. We have to use LM35 and display it on Bluetooth module first. Okay. We will first display it on LCD as we already done it, saving time. Okay. To display, okay, we'll do this. Display it on LCD and Bluetooth module. If you do that, both the things will be fulfilled successfully. So, start. First I have to take an output. First enter val and val equals analog read A0. Okay. Analog read came. I got an analog read. Serial. Yeah, see that went off. Serial dot print ln value. But I have to first convert this char C 20. First this is a character. First convert it to string. Val dot to array c comma 20. After converting it to array, then str comma c. Okay, into val equals analog read. It will read the analog input, print it on the period rate, serial begin, serial begin 5600. Okay, print the value and to print it on cmd 0x 01. Remember 81 and split it cmd. Okay, 0x 80. Okay, serial dot print temperature. Then str temperature. For next line it is C0. Then delay 400 seconds. Start. Down to 1. So there is this serial dot print delay. LM35. I got chips. I'll have them in simultaneously. Teacher. Now UV sensor, value changes here only. Pulse in is the most important. And like that we have to configure here 8 9. And is that trigger? Trigger. And is that? Not one. And is the trigger, 10 is the echo. Okay. Don't set rules for it whenever you want. Don't do these things. Okay. Okay, trigger. Okay. Trigger. Digital. Right. Delay. Microseconds. Trigger is set. 9. 9. I'll send it as high. And then value equals pulse in. High. Enter. We got the output. We should go to the next video.
If you have the there is like
read this.
okay, good afternoon, guys. We'll start. So today we'll go with the first I'll start with the keypad programming, and then and after that, so we'll see how to program keypad same as we did with the LCD. How to do keypad. So here we'll use the library function, because otherwise the keypad program will be very long. So we'll use the library here. Then after that we'll see a practical example. So we've been doing like basic programming till now. Like we've been using all the modules, and we've been using the most basic components like switches or LEDs and motors and things like that. So one of the so we'll see a practical example of UART programming. We'll use GPS. I'll share the library files right now. So we'll see GPS program and how to read the values from GPS. So there is a component available in Proteus, GPS component. So you can use that component, and we'll see how to read the values and how to get the GPS data, latitude, longitude data from a GPS module. So the program will be very practical. You can use it for your, if you have the hardware, if you're using GPS in some project, you can use the same program. The same program you can use with the hardware. Okay. So we'll first start with the keypad. So if you take keypad, actually keypad, there is an inbuilt library in I don't know if this is inbuilt. You should check in your in my software. It's already there. Maybe I added it, or maybe it's already there. You can check if to see if it is there. You can check in examples. If you have the library, to see if you have the library, you can check in examples. In examples, if the library is there, then there will be keypad, liquid crystal, and all these things are inbuilt. But keypad, I don't know. Maybe it's inbuilt, maybe not. You can check it in your examples.
Let me check it.
it is inbuilt, it will be there. Otherwise, you have to add the library in Arduino for Arduino folder. Arduino same as in Proteus. In Arduino, there is a library folder. In that library folder, you can just add the keypad.s, the files for the keypad.s library, and the library will be added. So I'll share the Proteus library files for the GPS here. So do the configurations, the copy pasting and all that right now. So we can continue without any interruption. So this is a library for GPS, and not this library. So it's the same procedure that we use for all the other libraries, ultrasonic and so copy paste to the program data folder in your library folder in your program data folder in C drive. Okay. So if it is a different version, maybe it is in program files. You can check library files. So copy paste it in the library files of Proteus. Okay, Proteus software. So this example here is a here you can open this program. This is not something I've written. It's an example program of keypad.h, a very basic example program. You get one single key from the keypad and print that key in serial, virtual terminal or serial monitor in case of Arduino. So this example you can open from the examples. If you have the keypad folder, keypad option here, and in that you can open the hello keypad. This is the most basic example, hello keypad. Then you can declare all the different values. So you can declare any kind of values here. So normally we are going to use a 3x4 matrix keypad. We're going to use a 3x4. Okay, I'll share the library files. Okay, everyone just add the library files. So I'll show you if you have the so how to add the library. Just open the so if you have your already installed Arduino, so this folder will be somewhere, like I don't know the type of method you used to use for installation. It may be saved in program files in C drive, or it can be saved in some other place, because we can install Arduino in two ways. We can install using the exe file, normal setup file, which is we can double click on the next, then automatically the folder will be created in program files. Otherwise, you can download the zip file and you can just extract the zip file. So that means you don't have to install it with the setup file. You can, if you directly just extract the file, then you can save it, save the folder. So this folder will be there. Then you can save the folder in some place, some drive in your system. So in my case, it is in this drive, and this is the folder Arduino 1. Depending on your version, and inside that folder there is libraries folder, lib and libraries folder. If you open libraries folder, you can see in my case there are so many other libraries. All these libraries are not inbuilt folder, some drive in your system. So in my case, it is in this drive, and this is the folder Arduino 1. Depending on your version, and inside that folder there is libraries folder, lib and libraries folder. If you open libraries folder, you can see in my case there are so many other libraries. All these libraries are not inbuilt. Okay, some of the libraries are inbuilt in Arduino, like liquid crystal and all that, maybe inbuilt in libraries, Wi-Fi libraries, maybe all those things are inbuilt, but most of these libraries are not inbuilt. I added these libraries afterwards. So you can download these. They are all open source. You can download these libraries from internet, and you can just copy paste the folder, extract the file, and copy paste the folder here. Okay. So you should check the library when you have the file, you should check the library name. Okay, so it should be exactly like keypad.h. In my case, it says keypad.h, and in my Arduino also it says the same thing, keypad.h. Okay, so I'll share this file, this folder here. So I'll share the folder. Just copy paste the folder to your library folder in your Arduino. Okay, in your Arduino folder. So this is a file keypad.zip. So extract the file and copy paste it in libraries folder. Okay. So while you do that, I'll explain the